Chapter 3, review question number 1, has a pulley, and on opposite sides of this pulley are these two crazy monkeys. And here's put this other monkey over here. There's his tail. Alright, and so we have basically one who has a mass of 22 kilos and one with a mass of 20 kilos. And it wants to know at what rate will the monkeys accelerate and what will be the tension in the rope. Well, the trick here is to realize that each monkey could be drawn as a separate free body diagram. We'll call this M1 here and M2 here. So for M1, it's M1G acting down and tension acting up. And for M2, same deal, tension acting up and M2G acting down. M2 is slightly bigger than M1 though, and so the length of M2G, if we're using vector scales, is slightly longer than M1G, and in fact it's greater than the tension. So if we have a formula considering, let's just look at M2, we would say, well, we know that the mass of M2, A, is accelerated at A. So this is the net acceleration of mass 1 is equal to M2A. Well, that's equal to M2G minus T. The mass that is accelerating it is its own mass, and the force that is slowing it down is the tension. I do the same thing for M1A. In the case of M1A, it is the tension that would speed it up and the mass that would slow it down. The inertia would slow down that mass. So in this example we would have tension minus M1G. Combining these two formulas we get the mass of the entire system, big M, times A is equal to, and I might as well just cancel these tensions now, is equal to M2G minus M1G. From this I will get 42, the mass of the combined monkeys, times A is equal to 22 times 9.8 G minus 20 times 9.8, the value of G, is equal to A, when we divide that sum by 42, of 0.47 meters per second squared. For the second part of the question, it asks about the tension. We return to our equation up here. Oh, sorry. We turn to this equation right here to solve for tension, rewriting it in terms of T. Tension is equal to M1A plus M1G. You could use either formula, but this one I just chose because I can make tension positive without having to move it to the other side. So I simply do the math. M1 is the 20 times the acceleration I just calculated, 0.47, plus M1 times 9.8. Tension after this calculation is 205.4 newtons overall.